find a 1 unit interval where there is a solution of this equation using,
sorry.
No, it's okay. IVT. There is no interruption, please. It never bothers me if you say something and while I talk, it never, that's not any issue ever. Go ahead.
I know you said you made this problem up. What section does this belong to?
Continuity, 2.5. 2.5, yes. 2.4 is epsilon delta and 2.5, continuity. So first of all, I have to create a function, x cubed minus 4 natural log of x squared plus 1 minus 3 equals 0. So this is my f of x. X to the third minus 4 natural log of x squared plus 1 minus 3. I have to say that this is continuous. It's a polynomial function. I have to say that this is continuous everywhere, x squared plus 1, continuous as a natural log. This is always continuous. So I will have to write f of x is continuous on negative infinity, infinity in this case, as a sum or difference, same thing, of continuous functions. Because if it's not continuous, not necessarily on all real numbers, but if it's not continuous on the interval that I find, then I cannot use the IVT. So this problem does not give us an interval. It does not give us the 1 unit interval where there is a solution. So what do? Very simple. I will put the function in the graphing calculator. In y equals, clear, the function is x cubed minus 4 natural log of x squared plus 1, close, and minus 3. I know the function is continuous everywhere. There is no restriction, no problem. I'm going to start by punching in numbers. I'm going to punch in 0. It's already there. I'm going to punch in 1. Did it change sign? No, it didn't. I'm going to punch in 2. Did it change sign? No, it didn't. I'm going to punch in 3. That's it. It must be a solution between 2 and 3. What is it? IVT doesn't know. We need chapter 4 to help us with that. But there is definitely a solution between 2 and 3 because the function is continuous and a 2 is negative and a 3 is positive. So I'm going to write f of 2. Don't even copy the number, it's not important. And f of 3 is positive. So by IVT, f of x has a solution. I would say a 0 better, or the equation has a solution. That's a 0. Or x-intercept between 2 and 3. What is it? I don't know. So there is that C in the interval 2, 3 open, not 2, not 3, such that f of C is 0. That's all you have to write. It's a continuous function, and I found an interval. I don't have to find more than 1. 1 is good enough. I found an interval in which the function changes sign. It starts at negative, goes to positive. It has to cross the x-axis. And this is a very important theorem for chapter 4. So that's IVT. So do you still want to work on an epsilon delta? Do we want to work on an epsilon delta? Please say something, please.
Yes.
Yeah.
Very good. So please give me a linear function, any linear function you want to work on. And let's create a limit or look in the book. I can open the book, whatever you want.
We can try 4x plus 5.
4x plus 5. And this is the limit. As x approaches, you tell me what?
7.
So 4 times 7 plus 5. What would that be?
33.
Very good. So there is the double equivalency. For every epsilon positive, there exists a delta positive such that 0 less than x minus less than delta will always imply x minus 7, of course, and the function minus 33. We always start here. So with 4x minus 28, and we always have to get this on the left-hand side. Very simple. Factor out 4. Do not factor outside the absolute value. It's not allowed. Do not factor outside the absolute value. Now you have to write this. Now we have to write this. And only now we divide by 4. Can anyone give us delta? By comparison, what could delta? Yes,
Delta equals epsilon over 4.
that's it. Don't forget step number 2 to say reverse. Show that delta equals epsilon over 4 works by reversing the steps from above. You don't have to write anything else. You don't have to reverse the steps. You just have to say, show that epsilon delta equals epsilon over 4 works by reversing the steps from above. That's it. Good. I don't remember what this 47 or 125 is. Let me look and see which section did I pick that from. Page 125, 125, continuity. Yes. And I'm sure we did that problem together. So that is in section 2.5. $47. I'm sure we did this problem in class together. Is this okay? Do we still have to work on that?
Yes, go ahead.
Okay, so for what value of the constant c, which is called the parameter, we have f of x equals cx squared plus 2x for x less than 2, and x cubed minus cx for x greater than or equal to 2. So they want us to find c so that this function is continuous everywhere. And like before, we have to write that cx squared plus 2x and x cubed minus cx are continuous functions as polynomials. But the question is continuity at 2. That is the only question we have. And now I'm asking you again, what is continuity at 2? How do I write How do I write continuity at 2? What is the definition of continuity at a point? Please help so we can Finish all the review, please.
When instead of f or x approaches a, now we would say x approaches
2 from the
2.
left. Awesome. Which branch?
on the right.
Yes. So which of these two? What do I put in here?
Oh, the coming from the left would be the first one.
Excellent. Cx squared plus 2x must equal the limit as x approaches 2 from the right of x cubed minus cx and must equal f of 2. So we make this equal. Okay? So can anyone give us this? Can anyone give us this and this? Anyone, please? What is this limit, and this limit? We want to move on, please.
Wouldn't it be 4c plus 4?
Excellent. What about this one?
8 minus 2c.
Excellent. And this one? And we have to use the same, so it will be the same. 8 minus 2c. These two quantities have to be the same. These are the same, but also these have to be the same. And this is the equation that will give us c. So therefore, we have 4c plus 4 equals 8 minus 2c. I bring 2c here. I subtract 4, and I get 4. So then c equals 2/3. This is good, but it's not good enough. I have to put it in the function. I have to replace c in the function by 2/3. So then I will say this is 2/3 x squared plus 2x for x less than 2. And this is x cubed minus 2/3 x for x greater than or equal to 2. And I have to state continuous on negative infinity to infinity. Guaranteed. This is guaranteed to be continuous everywhere. This is continuous everywhere, this is continuous everywhere, but now we made it continuous at 2 by finding this specific unique constant. Good. Or parameter. Okay, 5 on 124. So it's basically the same page, or the page before. I'm not sure why I chose that. Again, it's 5. Why did I choose 5? Oh, yes. The graphical function is given. Here it is. At what numbers a does this limit not exist? The limit from either side. Which numbers the limit from either side does not exist? Number or numbers?
1.
Only at 1. Because the limit from the left is a number and the limit from the right is another number. At 3, the limit from either side exists because the limit from the left and the limit from the right are the same. The function is not continuous at 3. It has a removable discontinuity at 3. But at 1 is not there is a jump. That's why the limit from either side does not exist. Awesome. At what numbers a is f not continuous? Of course, at 1 and at 3 is not continuous. At what numbers the limit exists? Does limit exist, but a is not continuous at a? We know that. It's at 3. The limit from either side at 3 exists. It's a removable discontinuity. But the function is not continuous at 3. Now, if you look at this function in 5, can you tell me where is this function not differentiable? The function is not differentiable at
1.
At 1 because it's not continuous. Awesome. At
3.
because it's not continuous. Awesome. And
Is that's 3, 4
4.
and a half?
Yes,
Yeah.
because
Corner.
because it's a corner. Awesome. Great job. Okay, very good. Thank you so much. Let's see what we have here. So the next in line is limits. Do we want to look at the squeeze theorem?
Yes, go ahead.
Okay, the squeeze theorem, it's still before. I put it in there so I don't forget about it. Just 1 second, I have to plug in my computer. Sorry about that. Okay. So I think it's in 2.3. The squeeze theorem. Yes, it is. Right here. So here's an example. We did one in class, and then we had one for homework. So let's choose one. I did not pick one for the squeeze theorem.